Ever stop to think about the high-performance hidden engine driving your vision? Well, if you want extraocular muscles anatomy explained simply, you are in the exact right place. Welcome to this explainer. Today, we're going to visually deconstruct this incredibly precise, super fatigue-resistant network of muscles that perfectly control our eyes. These structures basically act like a biological steering wheel, processing rapid-fire signals to keep our gaze perfectly aligned. So let's dive right into this fascinating system. So here's a wild question to start us off. Did you know your eye muscles are moving even when you're fast asleep? It's true. Unlike your standard skeletal muscles, these striated extraocular muscles pack special fibers that allow for incredibly rapid, continuous movements. Because they're constantly readjusting the position of our eyes all day long, they're actually considered the most active muscles in the entire human body. And the craziest part, it doesn't even stop when you close your eyes at night. These muscles just keep darting around during the REM, or rapid eye movement stage of sleep. Now, to put things into perspective, the sheer precision we're dealing with here is absolutely mind-blowing. Think about a normal skeletal muscle in your arm or leg. One single nerve fiber might control anywhere from 50 to over 125 muscle fibers. But for your extraocular muscles, that nerve-to-muscle fiber ratio is an astonishing 1 to 3, up to maybe 1 to 5. This incredibly dense wiring gives our eyes unmatched, literal pinpoint accuracy for those microscopic adjustments we need for focused human vision. Okay, before we map out the individual muscles, we really need to understand their main anchor point. Meet the annulus of Zinn. It's this fibrous, common tendinous ring located right at the back, the apex of the bony orbit, sitting just in front of the optic canal. As we're going to see in a second, this ring basically acts as the foundational starting line for the majority of the muscles we're covering today. Here's a quick roadmap for our explainer today. We've got 1, the eye's hidden engine, 2, the 4 straight muscles, 3, the 2 angled muscles, 4, the eyelid elevator, and 5, our key takeaways. Section 1, the eye's hidden engine. Every single person has 7 pairs of these extrinsic muscles housed in the bony orbit. 6 of them are there to maneuver the eyeball itself, and 1 is just to elevate the eyelid. Section 2, the 4 straight muscles, which are also known as the recti muscles. So the word recti actually comes from Latin, and it just means straight. That's because these muscles run in a direct, straight line, right from that annulus of Zinn to the white of your eye. Take the superior rectus, for example. As the name hints, it sits right on top. Its primary practical job is elevation, literally pulling the eyeball upward. But it's a multitasker. It also helps pull the eye inward, towards your nose, called adduction, and handles intorsion, which is a medial rotation of the eye. You can see how it stems straight from the top of the annulus of Zinn, and it's all wired up to the superior branch of the oculomotor nerve, which is cranial nerve 3. On the flip side, we've got the inferior rectus muscle. This one originates from the bottom of the annulus of Zinn and runs right along the orbital floor. Its main gig is depression, pulling your gaze downward. It also assists in rotating the top of the eye outward, away from the nose, which is an action we call extorsion. And just like the superior rectus we just talked about, it gets its signals from the oculomotor nerve, specifically the inferior branch. Now, let's look at the sides with a great side-by-side comparison. Closest to your nose is the medial rectus. Fun fact, this is actually the largest of the recti muscles, even though its tendon is the shortest. Its whole job is adduction, pulling the eye inward. Then, on the outer edge, we have the lateral rectus, and that handles abduction, pulling your gaze outward. Working together, these two are what give you that smooth, side-to-side sweeping vision. But notice the wiring difference here. While the medial rectus is controlled by cranial nerve 3, the lateral rectus actually has its own dedicated wiring from the abducens nerve, or cranial nerve 6. Section 3. The 2 angled muscles, otherwise known as the oblique muscles. All right, here's where it gets super interesting, and honestly, this part is often misunderstood. These oblique muscles control the really complex movements around the sagittal axis. But unlike the 4 straight rectile muscles we just went over, these do not originate from that fibrous ring, the annulus of Zinn. No way. Instead, they arise directly from the periosteum. That's the dense connective tissue wrapping the bones. That actually forms the bony orbit itself. Because of this totally different starting point, they approach the eyeball from a sharp angle, passing right below the straight muscles. Check out the superior oblique muscle. It is the longest extraocular muscle we have, and it features this absolutely brilliant biological pulley system. The muscle runs along the roof of the orbit until it hits a fibrocartilaginous loop called the trochlea. The tendon literally threads through this pulley, takes a sharp turn backward and outward, and crosses over the eyeball. Since it's so specialized, it's controlled by its own unique nerve, the trochlear nerve, cranial nerve 4, and it works to depress, abduct, and inwardly rotate the eye. Then we have the inferior oblique, which is completely unique. It is the single extraocular muscle that originates at the front of the orbit, right on the maxilla bone. It happens to be the shortest extraocular muscle, and its job is to elevate, abduct, and outwardly rotate the eye. And here's a crazy bit of trivia. About 10% of people actually have an inferior oblique muscle with 2 muscular bellies instead of just 1. Section 4. The eyelid elevator, the levator palpebrae. So now we're looking at that specialized 7th pair, the one that doesn't actually move the eyeball itself. This is the levator palpebrae superiors. Rather than shifting your line of sight, this triangular-shaped muscle acts kind of like a biological garage door opener. It arises mostly from the annulus of Zinn, courses forward right over the superior rectus muscle, and has one vital task: elevating and retracting your upper eyelid. But here is the most fascinating clinical detail about its anatomy. As the levator palpebrae gets closer to the eyelid, it widens out into this sheath-like tendon called the levator aponeurosis. Now, while it starts off as voluntary skeletal muscle, meaning you can control it, the underside of its far end actually contains involuntary smooth muscle cells, known as Mueller's muscle. And get this, that smooth muscle is controlled entirely by your sympathetic nervous system. That's your fight-or-flight response, which perfectly explains why your eyes naturally fly wide open when you're surprised or scared. Section 5. Connections and summary. Let's wire this whole network together. When we lay it all out in a summary matrix like this, the division of labor becomes super clear. Notice just how dominant the oculomotor nerve, cranial nerve 3, really is here. It powers the superior, inferior, and medial recti, the inferior oblique, and the levator palpebrae. The outliers are those highly specialized ones. The lateral rectus, pulling the eye outward, gets its juice from the abducens nerve, cranial nerve 6, and the superior oblique, with its fancy pulley system, gets its very own wiring from the trochlear nerve, cranial nerve 4. Okay, so if you take away anything from this explainer today, make it these 3 absolute core points. First, your vision relies on exactly 7 precisely coordinated extraocular muscle pairs per person. Second, that fibrous annulus of Zinn is the essential anchor point at the back of the eye for all 4 of your straight recti muscles. And finally, these are the most active muscles in your entire body, pulling off unmatched structural precision thanks to an incredible 1:3 nerve-to-muscle ratio. And that wraps up our visual journey of the hidden engine. I really hope having extraocular muscles anatomy explained simply made this complex system click for you. If it did, please hit subscribe for more simple medical explanations pulled directly from the source material. Oh, and before you go, drop a comment below. I want to know which fact surprised you the most today. Was it that awesome biological pulley system, or the fact that your eyes are actively working through your REM sleep? Let me know, and keep learning.